just to clarify, well, we'll see on the next slide. I was the lead maintainer on Samtools a few years ago, and since I moved to the University of Glasgow, my former colleagues at Sanger carry on maintaining it with contributions from around the world, and probably a disproportionate number of contributions from myself. So on the screen here at the moment, I've just got the abstracts of a couple of papers that came out earlier this year, looking back at the time that Samtools has been around. So Samtools grew out of the 1,000 Genomes project in about 2008, 2009. Prior to then, so I guess that was really one of the first large next generation sequencing projects that was building its own tools as it went. Prior to that, aligners had their own formats for outputting their data, which was not the best if you wanted to mix and match different tools. So SAM and BAM, the formats that grew out of 1,000 Genomes along with Samtools, rapidly have became dominant, and we're still using them today, and they're kind of synonymous with the raw sequencing data. So let's move on and look at let's find my right window and move on to the next slide. There we go. So yeah, that's just looking back in the early time. Well, it's looking back over all the Samtools releases since the beginning. So on the left there, 2008, 2009, that first little flurry, and then through into 2010 and 11 up to about 0.1.12. That's the initial flurry of Hung Lee and the other folk in 1,000 Genomes project, building the tools as they were going that they needed to analyze their data. The initial publication of SAM and Samtools was in 2009, and at the time, the 014 was the current version of Samtools. And in this period, in about 2012, my involvement, actually, my background was I came to bioinformatics in 2009. Prior to that, I'd been a computer programmer in industry. And I came knowing nothing whatsoever about genomics or biology in 2009, and started working with sequencing data, and which was an exciting learning curve. And so in those early days, I was working at Sanger and sending the occasional patch and bug fix for Samtools and BWA and those sorts of tools of that era. And I've highlighted there this period in 2012, 2013, when 0118 for a long time, which came out at the end of 2011, I think, was the dominant version of Samtools. It's the last one of those 1,000 Genomes releases, really. So it was the dominant version of Samtools for quite a long time, and with a sort of a Herculean amount of effort, mostly from Peter Danacek of the Sanger. 0119 came out, which had some multi-threading support for sort commands and for writing BAM files. But really, for that whole sort of 2-year period, that was the only movement in Samtools. And looking back at it from 2021 now, it doesn't look like a long period. But at the time, looking at it from that 2013 point, we'd seen a big flurry of activity, the few years of 1,000 Genomes and that big flurry of activity getting us to where Samtools was at the time. And then nothing. It had really lain fallow for 18 months, a year, a couple of years, which was an interesting state of affairs, because it's used as the nuts and bolts of people's pipelines around the world. And even then it did that pretty effectively. It wasn't always as fast as it could be. It wasn't always as flexible as it could be. And there was a need for it to do new things, and there was a need for improved compression and all these sorts of things. So Rich Durbin found some funding to restart Samtools development. And actually, I went to work for him. I shifted job and started working on Samtools full time. So this yellow period is the period when I was doing an awful. I was working on Samtools full time, and several of my Sanger colleagues were able to devote, anywhere from sort of 20%, 50% of their time. It was an excellent period, and we really did restart Samtools development quite significantly. I think the two main things that were very significant in bringing out this 1.0 release in mid 2014, and so that was quite an action-packed 18 months from the previous release to that one. I think the two biggest things were the CRAM file format. So that I'll talk about that a little bit at the end if we have time. But that uses different compression techniques that, depending on your data, but depending on your depth of your data, maybe it's half the size of a corresponding BAM file. There are a lot of research. There's a lot of analysis of the ratios there. So that's just an oversummary. The other major significant thing was the complete overhaul of BCF tools. So previously, BCF tools had been a small part of Samtools for dealing with VCF files. And had some of the variant calling that came with Samtools. This got split out into a separate package, a separate program, and massively improved and basically completely rewritten. So nowadays, and since then, Samtools for your SAM and BAM files and CRAM files, BCF tools for your VCF and BCF files and variant calling. And any number of other variant callers, obviously, but that's the sort of test bed for this group of mainly Sanger-based people. And also, this saw the introduction of htslib, which factored out the basic I/O routines and so forth from those two things. So Samtools and BCF tools both use htslib, as can other tools, other programs, if they want to. So that's the three projects that the programs got separated out into at that point, but were really sort of still worked on in concert. And then there's a succession of releases over the years since then. Those early years, they were a little bit. We were aiming for a quarterly or at worst 6-monthly release cycle, and in those initial years we didn't really manage that because there was just so much to do to bring things up to scratch, to fix bugs, to etc. Every single one of those release numbers there really represents a bunch of bug fixes and new facilities and so forth, which we'll see some of in a minute. And then after I came to Glasgow, my former colleagues sort of carried on, and they had someone else working full-time on it, and other people were able to dedicate quite a lot of time to it as well. And a chap in Glasgow sending quite a few pull requests, and other folks around the world. And there's that period in 2017, 2018 when they were just about hitting that quarterly release cycle. It was excellent. And then a little bit of a gap more recently, coming up to 1.10, which was a huge release for them. May or may not. It's a funny thing how sometimes internally there's massive changes but they're not necessarily reflected externally. So the reason why that one took a bit longer was greatly improved handling of the headers of a SAM file, and improved multi-threading, which you can see externally. So a lot of things are a lot faster. BAM reading and writing, and SAM reading and writing. And CRAM had always been multi-threading, but all the formats are now multi-threaded on input and output. So, if you give Samtools a lot of process threads, a lot of cores, then it can go quite fast. And leading through to the current releases, 1.13 earlier this year, 1.14 is imminent. It should be out any day now. I think they're really sort of just putting on the last final touches of that at the moment. So here's a picture of that group a few years ago in 2015. This was, Ewan had a little bit of a challenge between the Samtools group and the GATK group of who was going to get CRAM integrated into production tools quicker, and we won it on the colourful one on the end there. And that mention of GATK sort of brings us into this slide a little bit, which is htslib pulled out as a library useful for other programs. You can use it directly from C and C++, and there are also a number of bindings from other languages. The original ones were probably the Perl and Python bindings there. PySam has been around for quite a while, as has BioDB HTS. BioDB HTS, I think, hasn't been updated for a while, but PySam got back underway. It has been going the whole time, really, and most recently released a month or so ago. And several other languages, several others as well on top of that. I think the Ruby binding there is quite embryonic, but some of the others are quite well established and very useful for people in those various languages. The obvious one missing there is Java, and the reason for that is that Java has its own independent implementation from the folks at the Broad. So there's several different groups at the Broad Institute who, over the same period as Samtools has been evolving, have HTS-JDK and Picard were the main ones. So HTS-JDK is the equivalent of the htslib library, provides all the sort of substrate, and Picard is a bunch of tools similar to Samtools. GATK, of course, being their variant caller and their everything else, and their big toolbox of everything. Perhaps similar role to BCF tools and the trio of C-based programs from the Sanger, and that that's their variant caller as well. And a couple of other independent implementations, one in D and a recent one in Rust, which is coming along quite nicely and is one to watch if you're a Rust programmer and interested in those sorts of things. So yeah, the two main implementations of working with SAM and BAM files and so forth for years have been the Samtools suite and the Picard suite. So here's some performance measures looking at how Samtools has changed over the years and how it compares to HTS-JDK. This figure is from the htslib paper that I'll put the full reference to at the end. So what you can really see there is that there's been immense improvement in Samtools. So what's written there is Samtools 2013. That is the 0.1.19 final release of old Samtools, as it were. And so current Samtools htslib, these figures are from 1.10. I think the figures for the current version are probably pretty similar. That's like six-fold increase in write speed and ridiculous increase in reading speed, and it's Java people have their work cut out for them because it's a garbage collected language. It's a sort of a bigger, more heavy duty thing, and so it is a bit slower for that flexibility. But yeah, I guess as a Samtools advocate, I'd point at these figures and say, use your modern Samtools. It's great in terms of performance. There's some more detailed figures there showing the difference between current htslib Samtools and older Samtools, and in particular looking at the multi-threading figures for compressed SAM and for CRAM, and the takeaway there really is use multi-threading and don't be using Samtools 0119 anymore, because it's missing what of the order of 7 or 8 years of performance improvements and bug fixes at this point. And this is the list of the subcommands in that version of Samtools, which were the basic nuts and bolts of your pipelines manipulation tools of the time. Currently, the list has increased quite a lot. BAM-SHUF has been renamed to Collate. It's a tool. It's a sort of a cheap sorting tool. It brings. Well, it's a cheap unsorting tool. It brings like reads together. So it's kind of like a cheap form of sorting by read name. Indexing and access to FASTA reference files has been joined by indexing of FASTQ files. That's quite useful for long read technologies and that sort of thing. The other thing that's quite interesting here is all the tools that have been added there are other nuts and bolts things for your pipelines for manipulating read groups and other sorts of things. Those two amplicon commands there are some that appeared quite rapidly last year as part of Sanger's COVID-19 efforts. So there's bespoke tools in Samtools for the needs of the day. And carrying on that theme of getting back into the nitty-gritty of Samtools, to use it, you've got to install it. And ideally, you might have a compute cluster at your institute, and you might have system administrators who will take care of this for you. Or oftentimes people are installing things themselves. I build Samtools from source code myself, and that's relatively straightforward, especially if you study the instructions and the install documentation before you start. If you're used to doing that, then it's fairly straightforward. If you're not, then it's quite a difficult thing to come up to speed with, and frankly, there's no reason why you should need to do that yourself. Particularly because the various operating system vendors package it, and so Debian and hence Ubuntu and Fedora both have Samtools 1.13 fairly up-to-date packages in their repositories. If you have root access to your machine, then you can just install that, or maybe you can get your system administrators to do that. Or if you're on a Mac, or if you prefer otherwise, Homebrew has got up-to-date packages of these things as well. Or the other common answer is Bioconda. And this is a pretty good answer for if you need to install Samtools and any number of other tools yourself. It's also a different flavor of package manager from the other ones, in that it's optimized. It's designed for having multiple versions of things installed. If you've got one project that is using one version, another different project that's using a different version of tools X, Y, and Z, then it's quite handy to be able to install these things in parallel and keep track of what you've got when. So Conda is designed for that sort of setup of doing it yourself and maintaining multiple versions of things. And it's if you use that conda create command to create yourself a new environment that's got Samtools and BCF tools in it, then that will give you current Samtools quite easily. Provided, so let's look at some of the pitfalls that are quite common with bringing Samtools up via Bioconda. So the typical one is you get this error message, an incomprehensible error message about not being able to load libcrypto shared libraries, and this is very frustrating for people who just want to use Samtools and don't want to learn this kind of detail about the inner workings of their computer. And it's quite frustrating for the Samtools maintainers because 99% of Samtools activities does not require libcrypto. It's a tiny thing on the side. The only thing in Samtools that uses that is if you access files on Amazon S3 directly from Samtools, and otherwise you don't even need it. So it's slightly unfortunate that it has. We might, there are ways of abstracting this requirement away, which we might improve the Bioconda packaging to do. But the way to fix it, if you come up with if you get this error message, is that to look at what Conda is installed for you, and invariably what you find out that what you've actually got is a truly ancient version of Samtools. So if you get this error message, what you need to realize is you don't want to fix it. You want to rebuild your installation to actually have an up-to-date version of Samtools. And usually the best way to do that is to make sure that you're creating a fresh environment, separate environment from your other tools, just for Samtools. That's the easy way to avoid conflicting requirements that other tools might have. Or you may have the channels not set up correctly, so you can verify using Bioconda's installation instructions that you've got that all set up the way it's expecting. It requires packages from something called Conda Forge, and so that does need to be listed there. And the worst case is you may need to specify whatever the current version of the day is explicitly like that. And that will either fail or give you the current working version of it, which is what you want. So once you've got that up and running, I'll just dive in a little bit here to things that have changed in Samtools over the years. So very often you see this old-fashioned sort of succession of commands, a view and then a sort command. View to convert something to the raw aligner output into a BAM, and then you sort it and then you index it. And there's been improvements to Samtools over the years that means you can actually just write this all in one line as shown there. So I often look at this -SB that you see in older tutorials on the web and this sort of thing, and I think, well, that's really an indication that this is a very old set of instructions. You never need -S because all Samtools commands detect whether it's SAM or BAM or whatever, and have done for a long time since 1.0. And you don't need to specify -B for the output, because if you use -O outfile.bam like that, then it'll say .bam, I should probably make a BAM file. And one of the more recent features that's been added is this write index on the fly indexing, which means that as sort writes the output command, it will also write the index file. So you don't need this separate indexing step. So if you read the documentation and see what's new in Samtools, you can simplify a lot of existing pipelines, so that if they can depend on these more recent versions, then there's fewer moving parts, fewer things to go wrong, and generally things will be more efficient and faster. I also call out this little bit of shell redirection here. I always recommend using -O options. So that's an option built into Samtools to redirect the output, like that -O outfile.bam down there. That's always, I think, a better idea where it's available than doing a shell redirection like this. The primary reason for that is that if you are wrapping your scripts in NoHup or in some Slurm or LSF or other job submission facility, there's a risk with that redirection that you'll accidentally pull in the error stream as well. And that will corrupt your BAM file, it will make it unreadable, and you won't be able to see your error messages because they will have been redirected into your data file. And by using the facilities to redirect with -O built into Samtools and BCF tools and lots of other tools, you just don't encounter that sort of problem at all, which I think is a better way to be operating. We've talked quite a bit about file formats, and So there's an example of the first few lines of of what's probably many tens of thousands of lines SAM file there. And you probably do need to have some idea of what all that means, because you are going to spend a bit of time studying these files. It's a very flexible file format, and it's obtuse in some ways but flexible in others. So the file format there's the front page of the specification there. That also grew out of 1,000 genomes, and in about 2014 came under the aegis of the Global Alliance for Genomics and Health, which was set up in about that time period. And so there's a committee of the large-scale genomics group within GA4GH that meets each month and works on improving the specification. The intention is that it's going to be quite a readable specification. It's not. That's a bit variable, and so we're always interested in people raising issues or contacting us about parts that they find harder to understand, things that need to be clarified, or problems that they encounter reading these specifications.
John, we do have to move on to the next speaker very soon. So perhaps just like one closing sort of slide.
Sure.
Or perhaps have time for one question.
Excellent. I was going to dive into a little bit of a conversation about the CRAM format. I'll just mention that BAM is relatively simple-minded in its compression. Whereas CRAM is kind of a framework for a more extensible compression. So it's the well-known technique in CRAM is doing reference-based compression. So rather than representing the sequence data directly in the file, it says, okay, this is the data that is at chromosome 1 position 10,000 in your reference, but at location 15 is a T instead of an A. So it doesn't have to represent all the rest of the data directly. And this other major place for improvement is that it allows fairly arbitrary, it's got extensible compression codecs there. So particularly being able to use arithmetic encoding is a more modern encoding technique that enables much better compression. But that's basically everything I wanted to talk about there. There's various URLs there. Those papers are you can find the links to those at htslib.org, which is kind of the homepage for Samtools and BCF tools and the other tools there. And if anyone's got any questions, that would be great. Thank you very much.
Wonderful. Yeah, thank you, John. Certainly your slide showing just like a snippet of a SAM file really brought back memories, because I have spent an inordinate amount of time looking at those files in my terminal. One quick question that I was going to ask you is, obviously your work is interesting because it's essentially at the edge of software engineering and bioinformatics, and having dabbled in both, I can tell, hopefully without stepping on too many toes, that bioinformaticians can program. They're just not very good at it. So I'm just wondering if you've got any comments or thoughts about this.
Yeah. So yeah, clearly today I've focused on the software engineering side of it rather than the bioinformatics side, because that's my background, and I think it's an interesting thing. And I think to really succeed the way something like Samtools has it's great to have both. And so I think one of the reasons why Samtools is still around and still going strong and still seeing a lot of improvement is that it's had involvement both from bioinformatics people who know, and people who work very closely with the scientists who are using it, who are the scientists themselves using it, who know the sorts of things that it needs to be able to do, but working together with people with an engineering background. who can make it do that robustly. One of the things I think that's quite interesting in bioinformatics is that we deal with such ridiculous amounts of data. I can't really tell the difference between megabytes and gigabytes anymore, because I'm so used to dealing with 10 or 100 gigabyte files that a 10 gigabyte file feels small to me now. But actually it's not. And in other engineering fields, people are used to much smaller amounts of data to test, and much easier to test things, really. And so I think that's still one of the big challenges for engineering and bioinformatics, is realistically testing with these huge amounts of data that we work with. Regression testing is part of the answer. So testing the scientific output of different versions of your program, different versions of other programs, and ensuring that you're not missing variants now, that things have that. My take on reproducibility is that it shouldn't be tied down to a specific version of software. You shouldn't need to record that I used exactly this version of Samtools and BCF tools and every other caller to reproduce my results. If the results are truly meaningful, then they should be inherent in the input data, and you should be able to get comparable stuff from versions across the board of the same tool and of different tools, and therefore that really the engineers should be able to compare those in some way. So that's a very glib summary of a very difficult problem that really needs both sorts of people.
I have to say, I really like how politically correct your answer was. It was like, oh, Adam, they're not so bad at coding. We're as good at other things. I suppose. Well,
maybe I left stuff unsaid there.
So I'll come back to you for some politics classes, John. But listen, thank you so much for coming here. Thank you so much for talking to us about Samtools, which is huge and incredibly interesting. We do have to move on to the next speaker, as we're a little bit over time. So thank you so much, John. We'll stay in touch. Bye bye.
You're very welcome. Thank you.